Okay, now I will answer the most common mistake in test 5 of TESTBANK. The first question is question number 12, 58.7% correctly answered. So almost 40% is incorrectly answered this question, question number 12. Which of the following is correct for 2 points A and B for merry-go-round rotating about a fixed axis as in the figure? So again, merry-go-round is a rigid object. So for a rigid object, there are 2 points on this object, A and B, and we know that these 2 points will have equal angular speeds. So when I was comparing centripetal acceleration, because centripetal accelerations are the question AC and CB, AC at B, I have to use the equation with angular speed because angular speed is constant for both point A and B. So let's remember the centripetal force equation including the angular speed. AC is equal to R times omega squared. Because point A and B both have the same angular speed, just AC will be directly proportional to the radius. Yani the point which is a greater radius will have a greater centripetal acceleration. In here, point A is farther from the center than point B, which means point A has a greater radius. That's why it will have a greater centripetal acceleration than point B. So correct answer is going to be in this problem. When we are using the AC equation, we cannot use AC is equal to VT squared over R in here because VTs are different, not constant. So there are two variables which determines AC. But if we use AC R times omega squared, there's only one variable which determines the affects the AC because omega is constant. That's why we should continue with the equation which includes the constant omega instead of variable Vt. Now next question is question number 3. Question number 3. A satellite traveling at a constant orbital speed of 5 meters per second. Orbital speed is the tangential speed, yani speed along the circular path, in a 3.14 kilometer circular track. This 3.14 kilometer is representing the arc circumference of this circle, not radius. Some students asked me during their study that this question is incorrect, and then when I checked their solutions, I saw that they are writing radius. Now this is not the radius, this is the circumference of the circle, and that's why we should calculate first radius. What is the centripetal acceleration of the satellite? Now AC is the question. As I said, we are going to use equation AC is equal to VT squared over R. VT is given, but R must be calculated by using the circumference. We know the circumference of the circle is 2 pi R. So S is, of course, we have to convert this 3.14 kilometer to meter by multiplying 1000. If you multiply by 1000, it's going to be 3,140 meters. So 3,140 meters is equal to 2 pi, we know 6.28 multiplied by the radius. When we simplify 6.28, we will get radius of the circle, so which is going to be 3,140 divided by 6.28, it is 500. So radius of the circular path is 500 meters. Now we can use this equation for calculating AC. AC is equal to VT squared over R, which is VT is 5, square of 5 divided by 500. So square of 5 divided by 500, answer is 0.05. 0.05 meter per second squared is the answer. The next question is question number 14. Question number 14, it is in here. For an object moving a circular path, Which one may never be correct? Never be correct. So absolutely incorrect. So it's about the circular motion. Part A. The question is about a total's magnitude. In circular motion, a total equation, maybe you remember, a total we can calculate it by root of AC squared plus AT squared. Yani AT and AC determines a total. But if an object is in a circular path, AC absolutely exists because object is continuously changing direction. But AT can be zero possible if object is moving in a circular path with constant tangential speed. Yani AT is equal to AC possible if A total is equal to AC possible. Yani A can be correct if AT is zero. In which case AT is zero if an object moves in a circular path with constant tangential speed, yani uniform circular motion. B. A total is AT. A total is equal to AT is never correct because AC always exists. Yani in this equation, AC must be included by, as I see in part B, A total is without AC, so this is impossible. What about C? AC can be equal to AT in magnitude. Why not? Why not? So object can be speeding up and also turning on the circular path. So their magnitudes of the centripetal force can be same number. Why not? Magnitude can be 5 meters divided by or 5 meters per second square, or 10 or 10, 20 or 20. So we can arrange it. This could be possible, and able to do that. And last one is A total is greater than AT. Yes, A total can be greater than AT if there is AC. Always exists. A total is greater than AT, so this is also correct. So B can never be correct because always there would be an AC. A total equation must include AC. There is no way. Question number 13 is the next one. 13 is this question. A disk accelerates at the rate of 2 radian per second squared. So this is the angular acceleration alpha. Calculate centripetal acceleration of a point on the disk. So we are going to calculate the centripetal acceleration on a point on the disk, which is 0.2 meter from the axis of rotation, and this is the radius of that circle. After 4 seconds, it starts from rest. If it says after 4 seconds, it starts from rest. So initial angular speed of the disk is 0. So 4 seconds is delta t. Of course, after 4 seconds, this disk will gain another angular speed. So first we should calculate what is this angular speed, that final angular speed. Because at that final angular speed, we are going to calculate the centripetal acceleration. So I'm going to use the kinematic equation, especially last two years, they start combining two titles. Section 1, and for example, this question includes a question. Section 1 and section 2 possibles. So they start giving such questions in the ministry. So just I give this question this way. Omega final is equal to omega initial plus alpha delta t. Initial angular speed is 0. So alpha is 2, delta t is 4. So it's 8 radian per second. Now I will calculate what is the centripetal acceleration at that angular speed. I am going to use the equation for centripetal acceleration, which includes omega, because omega is known, r omega final squared. So r is 0.1 meter. Omega final is 8. I will square 8. Square of 8 is 64. Multiplied by 0.1, it becomes 6.4 meter per second squared. So B is the correct answer in here. Next question is question number 11. Question number 11. A body is moving on a circular path. At a point on the path, body's centripetal acceleration, this is AC, and its tangential acceleration is 30 meters per second, this is AT. What is the direction of the total acceleration theta with respect to the direction of motion? So theta equation we have in the book, but there is no problems, numerical problem with this equation, which is AC divided by AT, but possible they can give it, and they did this before. So tangent inverse, so AC is given as 40. AT is given as 30. So I'm going to just calculator, shift tangent bracket 30, 40 divided by 30, close the bracket, answer is 53. So 53 degrees is the angle. Next one is question number 18. Question number 18 is similar to the previous one right now we solved. The pattern is different a little. So it's 13.518 car traveling at 50 km per hour rounds a curve of radius 200 meters. Find the centripetal acceleration. AC is the question in here. This is given as tangential speed. This is given the radius. So VT is given, R is given. We can calculate AC by VT squared over R only. This is kilometer per hour. We have to convert this kilometer per hour to meter per second. So 50 kilometer per hour is equal to, so when you are converting kilometer per hour or any conversion, it is the method. 50 is the magnitude. Every 1 kilometer is 1000 meters, so because it's in the numerator, you should write it numerator. Every 1 hour is 3600 seconds, you should write it in the numerator. After that, multiply them. 50 times 1000 divided by 3600, answer is 13.9. So it's 13.9 meter per second. After that, we can now calculate AC. 13.9 squared divided by radius 200. So we will find the answer as 0.96. 0.96 meter per second squared. So A is the correct answer. And last question is 25. Question number 25 is mystery question, just about total acceleration again. A body is moving on a circular path. At the point on the path, the body's centripetal acceleration AC and its total acceleration A total. Now AC and A total is given in this question. Given what is the tangential acceleration? AT is the question. I'm going to use the equation for A total. A total is equal to root of AC squared plus AT squared. To get rid of the root, we should square both sides of the equation. So you will get A total square as AC squared plus AT squared. A total is given, which is 60 square of 60. Root is removed. AC is 50 squared plus AT squared. Square of 60 is 3600 equals square of 50 is 2500 plus 80 squared. When we transfer 2500 to the left side, AT squared is going to be 3600 minus 2500. So it's going to be 1100. When we get the root, let's get the root of 1100. It is 33. So AT and tangential acceleration is going to be 33 meter per second squared.